Hey there, this is video number 32 on annuities. We're practicing solving for S. So we're solving for the future value or how much we're going to have at the end. A couple of practice questions first, and then actually going to get busy and sorry, lights are flashing in the school. I'm getting a little spooked. All right, how about you turn off the video and do the questions? All right, here we go. So S is equal to, I start with my inside bracket. Add that up. I'm going to do my exponent. 1.005 to the 30th minus 1, 0.05. 0.005 to the 30th power, 1.1614 minus 1. Nope. Put my little dots in there to remind myself that I got lazy. Maybe I don't say lazy. How about let's say efficient and not having to write that up. So I'm just leaving it there on my calculator. I'm going to subtract 1. So at this point, this one should always be a positive number. Okay. So if it's not, something went wrong. I mean, that makes sense. You're talking about finance. You're never, ever, 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 ever going to get a negative number. At least not with the stuff we do. So S is equal to 100 times 0.1614, 0.05. So I did the minus 1 already. Now I'm going to multiply by 100, and I'm going to divide by 0.05 all at the same time, and I'm going to get 322.80. Okay, so one more time, I'm going to say, hey, why don't you just pause the video, do the question, and then come back and make sure that you've got it right and I've got it right. All right, here we go. 1.03 to the 80th power. That seems big, but you know what? It's to the 80th power, so sure, let's go with that. 10.6409. Actually, it's 08. It doesn't matter because I'm leaving it on my calculator. And I forgot the minus 1. 0.03. All right, so minus 1. 9.6408. 0.03 times 75 divided by 0.03. I think it's going to be a really big number. Yes, it is. 24,102.23. There we go. So that's how we do the math. Now let's look to see what it's going to look like in a question. Skippy invested $200 per month when his son was born until his son was 15. Savings account earned 4.5% per year and was compounded monthly. How much was there after 15 years? Okay, so one of the keys here is seeing the per month. And that should always match your compounding period. But that's a reminder that this is an annuity, not just a compound interest question. So he's putting in $200 first month, $200 the next month, $200 the next month. and that's going to get added up for 15 years. So you know what? Let's just figure that out for a minute. Let's imagine that Skippy didn't trust the banks, and he put in $200 a month times, well, 12 months a year, times 15 years. Okay, so this is months, and this is years. Let's just do the math there. 200 times 12. Okay, $2,400 a year. That makes sense. So you can see. Times 15 years. This really isn't part of the question, but you know what? I like doing that because that says if he just took it and put it in a coffee can under his bed, there should be $36,000 in there. Okay, so I know that when I do this question, there better be more than $36,000, because if there isn't, then either this is messed up or this is messed up. Let's see what we can do here. I'm so used to writing APIN. So we've got a P, an R. Hold on, I want to see my formula. It's been a while. Nope, an S and an R. There's no P in this one. I and N. Okay, now N is just like before. 15 years. In this case, it was per monthly and compounded monthly. By the way, a business student told me that's called a simple annuity. If the compounding doesn't match the payments, then it's not a simple annuity. I don't know if that makes it a complicated annuity, but anyway. Okay, so for mine, they have to match times 12. So 15 times 12 is there's supposed to be 180 time periods, 180 months there. Okay, so my interest is 4.5. 4.5 divided by 100 divided by 12, just like before. $0.00375. And what's different this time is R is our regular payment. That's 200. And our formula is different, of course. R, forgive me, put it over here, and I'm going to recopy it. It's been a while since I've used it. Bracket, bracket. 1 plus I to the N minus 1 over I. Okay, bracket, bracket, 1. All right, we're good to go. So S is equal to my regular payment, 200 times 1 plus 0.00375. Our N is 180 minus 1 over 0.00375. S is equal to 200 times 1.00375, 180 minus 1. I think I've said this before. If you, which line? Skip this line where you write that out, because we can all add 1. I'm okay with that. S is equal to 200. All right, 1.00375 to the power of 180. All right, 1.96155 dot minus 1 over 0.00. So S is going to be 200. Now we're going to subtract our 1. Again, just leave it all on the calculator. 0.96155 dot 0.00375. And we're going to do this all at once. So times 200 And if you want, if you're not sure about your calculator, hit the equals in between and then go divide by 0.0375. So 51,282. Oopsie, decimal 93. All right. So my answer seems lovely because we said if we just, I'm just going to call it the sock drawer. We put this money in the sock drawer, there'd be $36,000 there. We have 51,000. So annuities are actually a way more reasonable way to save than probably anything else, right? Because even, you know, if I have if I want $1 million, how much do I have to invest when I'm 18? Well, $17,000. Well, nobody has that. But I'm starting to rant. So my bad. Have a lovely day, and I'll join you for the next video.